Ever stand behind a car and feel that blast of hot air from the exhaust?
Oh, yeah.
It's more than just annoying.
Yeah.
It's a huge sign of wasted energy.
Right.
Today we're diving into a potential solution that's kind of straight out of the future.
Okay.
A way to capture that heat and turn it into something useful.
All right.
We're taking a deep dive into a recent article from the American Chemical Society called "Your Car is Wasting Energy and Scientists Just Found a Fix." It was published February 13th, 2025.
Okay.
And get this,
Yeah.
it claims to have a way to use the heat from car exhaust to actually generate power.
It's a fascinating development. And you're right, that exhaust heat represents a ton of wasted energy. The study highlights just how inefficient combustion engines really are.
Okay, so no more suspense. Lay it on me. How much energy are we talking about here?
A whopping 75% of fuel energy in a gas-powered car is lost as heat.
Wow.
That means only 25% actually goes towards moving the car.
So 3/4 of what we put in the tank is basically going up in smoke.
Yeah, essentially.
That's insane.
It is a lot.
And I'm guessing this isn't great for the environment either.
You're absolutely right.
Yeah.
All that wasted fuel means more greenhouse gas emissions.
Yeah.
Which adds to the problem of climate change.
Right.
That's why finding ways to be more efficient with our energy is so important.
Which brings us back to this new study.
Yeah.
They're talking about something called a thermoelectric generator.
Right.
What exactly is that?
Well, it might sound complicated, but the idea is actually pretty simple. Imagine you have a material that can conduct electricity,
Okay.
but only when there's a temperature difference across it. That's essentially what a thermoelectric generator does.
Huh.
It uses special materials called semiconductors
Okay.
to convert heat energy directly into electrical energy.
Wait, so these semiconductors can basically create electricity just from a difference in temperature?
Exactly, yeah.
That's wild.
It is pretty cool.
But I feel like I've heard of thermoelectric generators before. What makes this new design so different?
You bring up a good point. Traditional thermoelectric systems have had their issues.
Yeah.
They tend to be bulky, complex, and often need extra cooling systems to work properly.
Oh, kind of like trying to run a power plant from a campfire,
Yeah,
but needing a swimming pool to keep the generator from melting.
that's a great analogy.
Uh-huh.
But this new design is different.
Okay.
It's a lot more compact, meaning it could actually be integrated into vehicles. And get this,
Yeah.
it's designed to work best in high-speed environments,
Uh-huh.
like, you guessed it, car exhaust.
Okay, now I'm really intrigued.
All right.
How does this new design actually work? Is it really that different from older thermoelectric generators?
Well, it still uses those special semiconductors to create electricity from heat.
Okay.
But this time, they've added something called a heat sink.
Heat sink. Does that literally mean a sink for heat?
Exactly. It helps create a larger temperature difference between the hot exhaust and the cooler surroundings.
Okay.
And remember, the bigger that temperature difference, the more electricity you can generate.
So it's like taking advantage of that blast of hot air coming out of the exhaust pipe and turning it into something useful.
Yeah, exactly.
But how much power can it actually produce? Enough to make a real difference.
Well, they built a prototype and were able to get 40 watts of power.
Okay.
That's enough to power a standard light bulb.
That's pretty impressive considering it's basically running on waste energy.
Yeah, it is.
But a light bulb is one thing. What about something more powerful? Could this technology actually help power a car?
That's where things get really exciting.
Okay.
They ran simulations to see how the generator would perform in a high-speed environment like a car exhaust.
Yeah.
And you're not going to believe this.
I'm on the edge of my seat. What did they find? Okay, spill it. What kind of power are we talking here?
The simulations showed the generator could produce up to 56 watts in a car.
Wow.
To put that in perspective, that's
Yeah.
like 5 of those big lithium-ion batteries you find in electric cars.
So we're not just talking about powering a light bulb anymore.
Right.
This could actually make a real difference in a car.
Exactly, and it gets even better.
Yeah.
They also ran simulations for helicopters,
Okay.
where the exhaust is even hotter and faster. In those conditions, the generator could produce a whopping 146 watts.
Seriously.
That's like 12 lithium-ion batteries.
This is blowing my mind. We could be talking about a future where cars are partially powered by their own exhaust. Okay, I have to ask.
Yeah.
When can I get one of these things installed in my car?
Well, hold your horses just a bit.
Okay.
As with any new technology, there's still a journey from prototype to actually having this available for everyone.
Right.
This study is a big step forward,
Yeah.
but there are still some hurdles to overcome.
Like what? What's standing in the way of me getting a little extra boost from my tailpipe?
One challenge is figuring out how to scale up production.
Okay.
Right now, they've only built a small prototype. To make enough of these generators for all the cars out there, they'll need to figure out how to mass produce them efficiently and cost effectively.
That makes sense. I can imagine it's one thing to build one in a lab, but quite another to crank them out by the thousands.
Precisely. And then there's the question of cost. New technologies are often expensive at first.
Yeah,
Making this affordable for the average car owner is going to be crucial for widespread adoption.
I can see that. But even if it takes a while to become mainstream, the potential benefits are huge, right? I mean, we're talking about saving fuel, cutting emissions,
Yeah,
maybe even lowering our energy bills.
absolutely. This technology has the potential to be a real game changer, not just for the auto industry, but for the way we think about energy in general.
It's like turning what we thought was waste into a valuable resource. It makes you wonder, where else could we be using this technology?
That's a great question, and one that researchers are already exploring. Think about all the places where we generate a lot of heat as a byproduct: factories, power plants, even your laptop.
Whoa. So you're saying we could potentially adapt this technology to make all sorts of things more efficient?
Exactly. Imagine a future where factories are partially powered by the heat they generate,
Uh-huh.
or where the waste heat from your laptop helps charge your phone.
Now you're really getting me thinking. It's incredible how this one discovery could open up so many possibilities. But before we get too carried away, I'm curious about how they actually managed to overcome some of the limitations of older thermoelectric generators. You mentioned this new design doesn't need extra cooling systems, which was a big problem before. How did they pull that off?
That's a great question. It really comes down to two key innovations: the heat sink we talked about earlier,
Right.
and the fact that it's designed to work in those high-speed environments.
Okay, but how does that actually solve the cooling problem? Break it down for me.
Remember how the heat sink helps create that temperature difference? Yeah, which is what drives the whole process. Well, the high-speed airflow from the exhaust actually enhances the heat sink's ability to dissipate heat.
Okay.
It's like having a constant stream of cool air blowing over it, keeping it from overheating.
So it's like the car's own movement is helping to cool the system.
Yeah,
That's brilliant.
it is. They were able to leverage the existing conditions to their advantage, resulting in a much more compact and efficient design.
I'm so impressed by the ingenuity of this. But as much as I'd love to keep geeking out about the technical details,
Right.
I think it's time to shift gears and talk about the bigger picture.
I agree. We've laid the groundwork.
Yeah.
Now let's explore what this all means.
Right. What are the real-world implications of this technology?
Okay.
How could it change the way we live and consume energy? So we've gone from car exhaust to simulations to the possibility of powering factories and laptops with wasted heat. It's been quite a journey. But what's the takeaway for you, the listener? What does this all actually mean?
That's a great question. And I think one of the biggest takeaways here is the power of perspective. We tend to think of waste as something negative,
Yeah.
something to be discarded. But this research shows that what we consider waste can actually be a valuable resource waiting to be tapped.
It's like the old saying, one person's trash is another person's treasure. We just needed to figure out how to unlock the treasure hidden in our tailpipes.
Exactly. And that shift in thinking is crucial, especially as we grapple with the need for more sustainable energy solutions. Instead of just focusing on reducing our energy consumption,
Yeah.
we can also look for ways to be more efficient with the energy we're already using.
So this isn't just about driving less or turning off the lights when you leave a room. It's about finding ways to squeeze more out of every drop of fuel, so to speak.
Precisely. And this technology has the potential to do just that. It could help us reduce our reliance on fossil fuels, lower emissions, and create a more sustainable energy landscape.
It sounds almost too good to be true. But realistically, what needs to happen to take this technology from the lab to the real world? What are the next steps?
There are a few key areas to focus on. First, we need to figure out how to scale up production. Right now, we're talking about a small prototype. To make a real impact,
Yeah.
we need to be able to produce these generators on a massive scale and do it in a way that's both efficient and cost-effective.
Right. We need to make sure it's not just a cool science project, but something that could be integrated into the way cars are actually built and sold.
Exactly. And that brings us to the next challenge: integration. How do we seamlessly incorporate these devices into existing vehicle designs and infrastructure? It needs to be practical and user-friendly if we want people to embrace it.
It can't be this bulky thing that you have to strap onto your car. It needs to be built in, almost invisible.
Right. And finally, there's the ongoing need for research and development. This study is a fantastic starting point, but there's always room for improvement. We need to keep pushing the boundaries, exploring new materials,
Right.
and looking for even more innovative applications of this technology.
So it's not just about making what we already have better. It's about discovering what else is possible.
Exactly. And that's where collaboration comes in. We need scientists, engineers, policymakers, and industry leaders all working together to bring this technology to its full potential.
It's a team effort to build a more sustainable future, and this research shows us what's possible when we put our minds to it.
I agree. It's an inspiring example of human ingenuity and a reminder that even our waste can be a source of innovation.
Well, folks, that brings us to the end of our deep dive into the fascinating world of thermoelectric generators and waste heat recovery. Hopefully, you're leaving this conversation with a sense of wonder and possibility.
Yeah, it's been a thought-provoking journey, and we hope it sparks your curiosity to learn more about the incredible innovations happening all around us.
And here's a final thought to leave you with. Imagine a world where we no longer see waste, but only untapped potential. What could we achieve if we viewed every byproduct, every bit of excess, as a resource waiting to be harnessed? Until next time, keep exploring, keep questioning, and keep diving deep.